Okay, as you can see, we are starting our new chapter that begins with Pythagorean's theorem. And as I've mentioned before, you've seen Pythagorean's theorem before. We talked about it very, very briefly and kind of sketchily at the beginning of the year. You theoretically saw it last year in Algebra 1. Most of you paraphrase Pythagorean's theorem to say what? A squared plus b squared equals c squared. I want to be really, really specific about what A, B, and C are, of course. Notice that in your notes, A, B, and C aren't just numbers. A and B are the lengths of the legs of a right triangle. C is the hypotenuse, in which case, yes, absolutely. A squared plus B squared will definitely equal C squared. And if we take that property and consider the name of the next kind of numbers, I would hope it would make sense that a Pythagorean triple of numbers is just a trio of numbers for which a squared plus b squared would equal c squared. That's all a Pythagorean triple is a set of whole numbers. Please realize they have to be nice, pretty numbers, no decimals, no radicals, no yucky stuff. Nice, pretty whole numbers in order for these to be a Pythagorean triple. Okay, so you've seen and you've dealt with Pythagorean's theorem to some degree before, so we should be able to get through this fairly easily. In problem 1, I'm being asked for the length of the hypotenuse. Don't just give me an answer, give me an equation. One person, please. What equation am I setting up in order to find the length of the hypotenuse in this right triangle? Grace. Absolutely. Leg squared plus leg squared equals hypotenuse squared. Simplifying our equation, we have 64 plus 225 equals c squared. Continuing to simplify our equation, we have 289 equals c squared. So I would hope it would make sense that c is the square root of 289. And oh, there's those radicals again, Mrs. Clouse. I hate those radicals. Do I have to simplify this one? No, I can just evaluate it. The square root of 289 is, in fact, a nice, pretty number. So we're in luck here. C is 17. There is a your turn for this problem, and when you have calculated its answer, please type it into the Centio. We will be starting trigonometry on Friday. So if you still don't have a scientific calculator, you want to get one. A lot of these apps on the phones won't do what we need them to do. Yeah, no, part B we will discuss together. All I'm asking you to type into the Centio is the numeric answer for the part A. I did start the question. It is acting like I don't have a question. Huh. Okay, my smart program isn't acting too smart right now. It's not showing me our results. Hopefully, you found the answer to be 26. Before I go any further, if you didn't get 26, that's the conversation I want to have. Are we good? Okay, the part B of that is asking, do the side lengths in part A form a Pythagorean triple? Ladies and gentlemen, what do you think? Do those side lengths form a Pythagorean triple? Yes, by sheer virtue of the fact that we solved an equation in order to make sure that a squared plus b squared equals c squared, we've complied with that. And by virtue of these three numbers being nice and pretty, yes, this is a Pythagorean triple. In problem 2, we are being asked for the value of x. I would hope that you notice the difference here. Here we're being asked for the value of a leg. Someone else, please. What equation would I use in order to solve for x here? Zoe. Say that again, please. X squared plus 10 squared. Let's use the variable that they're using. Equals 16 squared. Absolutely. And then we're just simplifying. So x squared plus 100 equals 256. Getting x squared by itself, we have that x squared is 156. And we need to simplify a radical, because x is the square root of 156, and that is not a nice, pretty number. So any thoughts on what 156 is divisible by? If you haven't by now, kind of by accident, memorized that list of perfect squares, you might want to make sure you're writing it down. So 156 is divisible by 4. And when I divide 156 by 4, I get 39. So our answer is 2 radical 39. There is a your turn. Take a moment and work through that within your group. Okay, from what I'm seeing and hearing, you're ready to compare your work to mine. Please do so. If something is off or unclear, once again, these are questions I want to address. We have from the screen what we need? Not yet. Thrilled to see someone who's moving on and glancing ahead. Oh, what's this? We good on this screen? All right. All right, in this example, we have a ladder leaning against a house, and we're being asked how high on the house the ladder reaches. So this time they're giving us a situation and asking us to represent a diagram, or it'd be helpful if we had a diagram to represent this. Could someone come up to my screen and draw and label the diagram with the measurements in place? Can you come up to the screen, please, and draw the diagram, putting the measurements in place? Chris, go ahead. Fantastic, yes. Very frequently, I'll have students put the 12 here because they didn't read the question where it says the ladder leans against the house. From here, we're doing exactly what we just finished doing on the previous screen. We're setting up and solving an equation for x. One person, please. What will this equation look like? Helena. Fantastic. X squared plus 4 squared equals 12 squared. Simplifying our equation, we have x squared plus 16 equals 144. So x squared is 128. And notice this time the instructions are asking us to the nearest 10. Read the questions, ladies and gentlemen. This time, we don't have to worry about simplifying the radical. Just evaluate in your calculator what the square root of 128 is. So that's 11.4. 3. And there's our answer. And within your groups, please work through that your turn problem. And give me a minute before you try entering it into the Centio. Okay, it says the question has been started, but I'm not 100% certain that it's understanding me. When you find your answer, please type it into the Centio. It's not letting you? I love technology when it works. All right, so much for the Centios. Make sure you're reading the question. I'm sorry? Read the question. Think about this tree, okay? It was like this. And then here's where the Bible is. You know that. Wow. Okay, so far I've seen one person that figured it out. Read the question. Some of you are doing the right steps, but you're circling an answer that isn't the answer. Read the question. Okay, I'm seeing a lot of you. Let me have your attention up here, please. I'm seeing, as I said, a lot of you get the mechanics of where to start with this problem and what numbers to plug in and how to solve for x. And a lot of you have something like 11.2 on your paper. But it's not the answer to the question. Question is asking you, how tall was the tree to begin with? That 11.2 that you found is how much of the tree looks like this. You have to add it back to the 5 feet that's still standing. Okay, the correct answer is 16.2. Before I go any further, if that 11.2 didn't come to you, the 16 you're not seeing, then that's a conversation I want to make sure to have. Yes? Okay. Visually, what you needed to realize, gentlemen and ladies, let's go ahead and turn the Centillos off. They're not cooperating with us today. Sorry. Okay, what you needed to realize in this problem is that this was a tree, and it was very beautiful. And then lightning struck it, and this fell here. It struck it 5 feet above the ground. And then when it toppled over, it's touching a point on the ground 10 feet from the base of the tree. So you would use Pythagorean's theorem in order to find the hypotenuse of that triangle. 5 squared plus 10 squared equals x squared. Okay, so those of you that had the 11.2, you solved for this diagram beautifully. But once again, it's that matter of reading the question. Guys, ladies, gentlemen, I know some of you may think, Mrs. Clouse, she's out to get us. She throws these awful questions at us. That's what the EOC is going to be, ladies and gentlemen. And I'm not trying to trick you. I'm trying to prepare you, because that's what you're going to see. You've got to read the question. So once you found that x, you needed to add it back to the 5 in order to find the height of the original tree. Okay, we have on this screen what we need. Okay, the Pythagorean theorem has a converse, of course, that we can use to determine what kind of triangle we're looking at based on the lengths of its sides. I hope that you realize that the strict converse of the Pythagorean theorem, well, let's rehash what the Pythagorean theorem says. The Pythagorean theorem says if right triangle, then a squared plus b squared equals c squared. I would hope that you'd realize that strictly its converse is saying if a squared plus b squared equals c squared, then it's a right triangle. Okay, so if a triangle has side lengths a, b, and c such that a squared plus b squared equals c squared, then the triangle is right. When we are using these inequalities to determine what kind of triangle the triangle is, we'll put these phones away, ladies and gentlemen, it's not going to help you. I would urge you, instead of thinking a squared plus b squared and c squared, flip the whole expression around and start with c squared. It's just a lot more intuitive that way. Okay? And what I mean by that is, look at what it says in your notes. If c squared is greater than a squared plus b squared, what does your gut instinct want to think that this is when you see that greater than sign? Obtuse. Exactly. Whereas, if you were looking at this inequality the other way around, you'd be looking at the same numbers, but you'd be looking at a less than sign. And that less than sign may lead you astray to thinking that that's an acute triangle. So again, I really want to stress to you, put the c squared on the left so that the answer looks the way it should look. Okay? And then finally, if c squared is less than a squared plus b squared, the triangle is acute. So in problem 4, I have a triangle with those side lengths. I'm being asked, is this a right triangle? What you're being asked, ladies and gentlemen, is, does a squared plus b squared, in fact, equal c squared? So that's what we're checking. It's a yes or no question. Yes. Problem 5 is asking us a more general question. It's not asking us specifically whether this is a right triangle. It's asking us what kind of triangle this is. And since that's the way it's asking it of us, once again, remember the biggest piece of advice that I can give you about this kind of problem. Bring the c, which is of course your longest side, over to the left-hand side of the expression. So I have 12 squared, and I'm trying to determine what's going to fill in the blank of this expression. Because if it's equal, it's right. If it's greater than, it's obtuse. If it's less than, it's acute. Okay, so 12 squared blank, 4 squared plus 9 squared. And then we're simplifying and comparing. This is 144 and 16 plus 81. I would put a greater than sign between those values, and that would make this triangle obtuse. Okay, there's a your turn, and I built something a little interactive on my smartboard notebook. Hopefully it will work. When you figure out what kind of triangle any one of these is, feel free to come up, click and drag it into place. Again, you should be working through that your turn, figuring out what kind of triangle is represented by each trio of numbers. There is one of each, and I would love if some bold, brave mathematician, on finding an answer for one of the triangles, would come up and click and drag it into place. No gold graded mathematician. The world doesn't have room for wimpy mathematicians. The numbers, drag the numbers. Yes, gold, grade. Take that away. And then select it again. Put it inside. Okay, it likes it. Someone else. Thank you, Helena. Fantastic. Someone else, please. Oh, well, there's the end. No. You know that's going to be a right triangle. Okay, I'll be activating a daily quiz on Socrative. There's an assignment on the board.